Okay, so in lesson 4.3, we talked about how exponents and expressions change what we call the expression, and I actually gave you guys a little table that kind of went over what to call the expression based on what exponent you see there. And what we're focusing on today is just distinguishing whether something is linear or if something is not linear. And not linear means anything else. Okay, so we're looking at expressions that have just a exponent of 1, and anything that's not linear is anything that has a different exponent than 1. So to take a look at some things here, so if I were to write 2x plus 3, we know there's no exponent that we see here, but we should know by now that it's secretly 1. So this is what we would call a linear expression. However, if we see something like 2x squared plus 3, this is no longer linear because of this 2 here. So we would call this nonlinear. Okay. Similarly, there's some things that maybe look like they have a power of 1, but they don't really. So for example, I could have 1 over x plus 5, and you may be thinking, oh yeah, this x has a power of 1. Even though it's invisible, I know there's a 1 there. But you also have to remember your exponent laws, which say that if you have an x on the bottom, if you wanted to know the real power, then you would move it to the top and make it the opposite, right? So I know this is really an x to the negative 1 in disguise, right? And since that's not a normal positive 1, this is also nonlinear. So this is one you're going to have to watch out for. This is like a sneaky one. If you see a 1 over x, that's not linear. It's just pretending to be. Okay, so what we're going to do first is we're going to circle all the expressions in this box that are linear in this table. And any of them that are not linear, put an X through it. So you can go ahead, pause the video, and do that right now before we move on. Okay, so looking at this first one, I see I have an X, and it's just to the first power. It's not in a denominator or anything like that. So that's linear. I'm going to put a big L next to it. If I look at the one beneath it, this one is not linear. It is not linear because of this x squared. So I don't want x squared when I'm thinking about linear things. I'm just looking at x's. So here you might be a little confused with this one below it, but remember if you distribute this, this is just 11x plus 22, and this is linear because we just have an x. Okay, looking at the next one, we have negative 8x plus 7 over 9 minus 3. Again, I'm looking at the x. It looks fine. It's not in the denominator. It has no power, so a power of 1. So this is linear. Okay, now this one might be a little bit tricky for you. You might be thinking, well, there's an x here and an x here, so maybe it's not. Okay, but when we combine these, the x is still going to just stay x, and it's still going to have a power of 1. So this is actually linear. If I can get it to circle it. Okay. Looking at the next one, again, you might be thinking, well, I don't know, there's an x here and an x here. Maybe that's too much. Nope. As long as they're just x's and you're not multiplying them together, then this should be fine. It should still stay linear. Okay, we have a few more to look at. 9 minus x squared. Can't have that x squared. That's not linear. So we don't want this one. Looking at this one here, I have x over 2 to the third power. Third power is not linear. So not linear for this one either. And the last one has an x to the negative 4. It does have a regular x, but that's not it. So this x to the negative 4 makes it not work. So this one's also not linear. Okay, so the rest of today's lesson is actually going to be us practicing what we did last week when we were writing expressions for these word statements. But beyond that, once you write your expression, you're going to actually tell me whether the expression you wrote is a linear statement or expression, or if it's a nonlinear statement or expression. So let's get back to what we know we're supposed to do when we're writing expressions. So the one thing that I saw a lot of people not doing, even though you did it in your notes, is writing expressions by first defining your variable. If you don't tell me what your variable is representing, your variable means nothing to me and nothing to anyone else that's looking at your problems. You need to define your variable. Okay, after that you want to identify key operation words. So these are words like sum, difference, squared, all of those words that you're used to reading and saying. You need to identify those to kind of break your expression up into pieces that you can then piece back together. Okay, so I'm going to ask that you make sure you're writing everything that I'm writing, because I don't write this just for fun. I do it because there is a reason that I want you to do it this way, and that's because you will get it right if you do it this way. So looking at this problem here, it says the sum of a number and 4 times the number. So I see when I'm reading this problem, there's a lot of mention of this number here. So I'm going to define my variable, and I'm going to let x be a number. You can even put a number sign for the number. Okay, that's how not picky I am. You just need to define it, tell me what it is. Now, I'm going to insist that you do this. I want you to write this statement over again, and instead of writing a number, I want you to write x. So, the sum of x and 4 times x. So when I do that, it's a lot easier for me to understand what's happening in this problem. Okay, now I'm going to look at some keywords, and the keyword that I see in this problem is sum. And there's actually something really cool about sum, is if you say sum of and then you look for the and is actually representing your plus sign. So that tells you what two things you're actually adding together. So in this case, it tells me that I'm adding x and 4 times x. And lucky for me, I know how to write both of those things. X plus 4 times x. Okay, and that would be my final answer. Now when I look at this, I know if x plus 4 times x is really just 5x, right? So I know it doesn't change the x. So make your decision right now. Is this a linear statement or is this a non-linear statement? I'm hoping that you said this is a linear statement. Okay, let's move on to the next one. So again, we're going to read the problem. We're going to try to figure out what is it that they're talking a lot about, but they're not actually telling us anything about. So the cube of a positive number divided by the square of the same positive number. So it seems like positive number is what we don't know. So we're going to define our variable. Let x be a positive number. And then I'm going to rewrite this statement, and instead of rewriting positive number, I'm going to write x in that spot. So I'm going to write the cube of x divided by the square of x. Okay, so then I can break this down into the expressions that I know. Cube, that means taking something to the third power. So cube of what? What am I taking to the third power? I'm taking x to the third power. So right here, I know this is talking about x cubed. Okay, if I look at something else that I understand, square of x, that means I'm also taking x squared. Okay, now they tell us very straightforward that we are taking the cube and we're dividing it by x squared. So I've been noticing that some of you get confused when you're setting up your fractions to do division. If this is being divided, then this should be on top. Okay, so that tells me I have x cubed on top of x squared. Now you may be looking at this expression and you may be thinking, well, there's a cube and there's a square, so there's no way this is linear. But we need to remember our exponent laws. In our exponent laws, we would cancel these out. we'd be left with just x to the first power. And x to the first power is what? It's linear. So this is one that was kind of like in a disguise. Okay, let's take a look at our next problem. This one's a little bit different. An admission fee of $10 plus an additional $2 per game. Okay, so they tell me how much it costs to get in, and they tell me how much it costs to play a game, but they don't tell me how many games we're going to play. So I don't know how many games we're playing. So I'm going to let x be the number of games played. And then I'm going to rewrite the statement. Instead of saying per game, I'm going to say per x. Okay, so admission fee of $10 plus, right, $2 per x. So sometimes when we have this per word here, it can be pretty confusing. Sometimes it means division, sometimes it means multiplication. So you really have to take a look at the problem and ask yourself, well, if this was me, how would I figure out how much money I need to spend or how much money I'm going to spend? So if you were going to play 2 games and it costs $2 per game, how would you figure out how much that's going to cost you? Hopefully you say, well, I'd pay $2 2 times, so I'd do 2 times 2, or I'd add 2 plus 2 and I would get 4, because that's what we're thinking about here. Okay, so one thing we know that doesn't change is you have to pay $10 to get in. So we're starting off with $10 right off the bat. We know we're adding $2 per game, which we just talked about, is 2 times the number of games, so 2 times x, and there you go. Go ahead and write down whether you think this is linear or if you think it's nonlinear. Hopefully you said it's linear. This is an x to the first power. There's nothing else going on in this problem. Okay, let's move on to the next problem. A number decreased by 3 squared. A number decreased by 3 squared. So they don't tell me which number, which means this is our variable. Let x be a number. Then I'm going to read this again. X decreased by 3 squared. Okay, so I see some keywords in here. Decreased and squared. So 3 squared, we should know how to write that. That's 3 squared, like that. We can even say it's 9, right? And x decreased by this amount. So if I'm starting with x and I want to decrease it means to become less, right? I want less than this amount. What should I be doing with this value? Should I be adding this to x, or should I be taking this away from x? I'm hoping that you said that I'm taking it away. So I have x take away 9 or x take away 3 squared. Okay? Now, go ahead and write down whether you think these expressions are linear or nonlinear. So I think you might get confused with this 3 squared. Okay, remember when we talked about linear and nonlinear, we said linear is something that has a term with a first power only. Okay, that means specifically variables, not so much numbers, because I know 3 squared is really just 9, so this is still considered linear. Okay, let's take a look at our last example. The sum of twice a number and 4 times a number subtracted from the number squared. Okay, so this problem is actually pretty interesting because of the way I typed it up incorrectly. What I need you to do is to put a comma right here. That way we know that that's a statement, and then the rest of it is a different kind of statement that's separate. So we should know by now that they're talking about a number. They tell us a lot about this number. So let x be a number. And then I'm going to write it again. The sum of twice x and 4 times x subtracted from x squared. So I like this word problem because there are a lot of keywords in here for me to use. So first off, I talked about the sum, right? I said if you see sum of, then you want to look for the and because that's your plus sign. Okay? So that lets me know that. Then I know that this means I have the sum of twice x, so I'm adding 2x and I'm adding 2x to what? 4 times x, which is 4x. Okay? So I'm going to write that down. 2x plus 4x, that's the sum. And I'm subtracting this away from x squared, which is another thing that I know how to write. X squared. Okay? So my question to you is this. They're telling me I'm taking the sum and I'm subtracting it away from x squared. So when I write my expression, what's coming first? The sum or the x squared? If you're taking something away from something else, right, whatever you're taking away from should come first. So we actually want to have our x squared first, and we're taking away the sum. This is the sum. 2x plus 4x. My x's are not working right now. Okay? So looking at this expression, would you say that this is linear or nonlinear? Okay, we may actually have to take a closer look, right? So I know this really breaks down to x squared minus 6x. We should know by now that I can't do anything with these two. This is x squared. They don't combine. Okay, so that means there's no way for me to get rid of this x squared. And if there's no way for me to get rid of it, this is a non-linear statement. Okay, so for your group work, you have 6 problems total. I do expect you to write let x be this number, as well as to rewrite your statement and writing x. I should also see you replacing keywords with symbols as you piece together your expression.